So, okay, we are on bearing of a point relative to another point. Here, before I will solve these questions, please, we need to revise the alternate angle theorem, which states that if you have two parallel lines and a line that considers the transversal, that alternate angles are formed. So I'm saying that angle here is the same as angle here, while the one here is the same as this. So that's it, alternate angle theorem. Another thing, in any equation, we need to know the starting point, which is from. So like this question, they say the bearing of B from A is 150. Bearing of B from A. So we started from A to B. Is north, south, east, west. North, south, east, west. So they said the bearing is 150 and you know this is 90, so this angle remaining here is 60. That's 90 plus 60. So to get the bearing of B, to get the bearing of A from B, we start from B. So where it hits the bar connecting the two point, that's what we have to find. And as you can see, this 270, that's 90, 90, 90 plus 60, because this alternate to this alternate angle theorem. So the answer is 270 plus 60, which is 330. So that's it. So it's very important. So again, here the same thing. The bearing of Q from P is 40. So from P, we move to Q. The bearing is 40, so this is 40. By alternate angle theorem, here is also 40. This is a transversal, this is parallel, you know, it's a vertical line, so it's parallel. So we're asked to find the bearing, this is P, from P to Q. So we are trying to find this. So as you can see, this is 90 plus 90 plus 40, so 180 plus 40. The answer is 220. So it's very easy. Or maybe we are asked to, the bearing of A from B is 3/3, so north, south, east, west. So we started from B to A. This is 3/3. This is 90, 90, 90 plus 60. 90, 90, 90, 270 plus 60. So this is 60 degrees. So here is also 60 by alternate angle theory. So what we are asked to find is the bearing of B from A. So this A, this B. So we are looking for this angle. As you can see, this is 90. So the answer is 90. The answer is 90 plus 60, which is 150. So it's very easy. We are now given 3 points and we are given the bearing of 2 points, and we are asked to find the bearing of the third point with respect to, as relative to any of the points given. So they say the man walks 200 kilometers due west from X to Y. So this is north, south, east, west. Started from X and moved, this is a straight line, and moved to what? To point Y, 200 kilometers, and move north to Z. He then walks 200 kilometers again, so 200 kilometers to Z. And we're asked to find the bearing of Z from X. So we need to connect Z. So we have to, from X, so this is X, we have to get this angle. And as you can see, we have a right angle triangle. So from what we call 45, 45, 90 triangle, the angle here is 45. Yes. because this 90 is this an isosceles right triangle for 70 plus 45, which is 315. So why the last one on this? The man walks 200 kilometers due west from, okay, the same, almost the same question. Walks from Z, from X to Y. And after walks north from Y to Z, we are asked to find the bearing of Z from X. But the distances are different. They say from west is, that due west is 200. Y due north is 200 times root 3. So without wasting time, there's a theorem called 30, 60, 90. So if you have 30 degrees, you have 60 and 90, that the ratio of the side is 1 is to root 3 is to 2. Yes. So once you know the one opposite 30, you've known the other one. The other one is x times root 3. Why this is 2s. So that's why here is 200. Here is what? 200 root 3. So here is 30. Why here is 60. Even you can get the value here. The length here is 400 without wasting time. So that's the theorem 3069. Very important theorem. The ratio is 1 is to root 3 is to 2. Once you know it's a 3069 triangle. So the bearing we are looking for. Okay, we did not finish this question. They say the bearing of X from Z. So from Z now, we move wherever it hits the bar. Remember, this is a, so this is 45. The remaining here is 45. So plus 90. So the second question, this is the first one. The second one is 90 plus 45, which is 135. Sorry for forgetting that. Why this? The bearing of Z from X. So from X we move and hit the bar. So the answer is 270 plus 60. As you can see, at 60 degrees. So the answer is 330. Why the second one? The bearing of X from Z, as you can see, this is 30. So the remaining angle here is 60 because of the quadrant. So 90 plus the second question now is 90 plus 60, 150. So that's it. Just draw a neat diagram. You will solve that. Okay. We're on distance between 2 points, given the bearing and distance between 2 points. So common sense will tell us that if you have 3 points that are connected, okay, maybe 3 points with their bearing, joining the 3 will form a triangle. Since we are given the bearing of 2 points and the distance between 2 points, so the major question that comes in here, maybe if you are given this, with this you know this angle, or maybe if you are given the bearing here, maybe from that you know this angle. So the problem, if you know the distance, maybe if here is A, B, C, so you might be given this distance and this distance. So you're asked to find this unknown. So you can now see that for us to solve the unknown side and maybe unknown angle of a triangle, we either use sine rule or cosine rule, if you remember. So we normally use cosine rule if we are given either 3 sides. Cosine rule if you are given 3 sides, or if you are given 2 sides and an included angle. we use cosine rule. Included angle means that you are given this, maybe if you are given this side and this, the angle between these two is called the included angle. So we use cosine rule. And how do you state it? It states that given this b small letter b small letter a, it states that assuming a is the unknown, so a squared is b squared plus c squared minus 2bc, cosine of the angle between the two, which is a. So if you are looking for a, the angle here is a. If you are looking for b, it's now a squared plus 6 squared minus 2ac cos b. And if you are looking for c, it's now a squared plus b squared minus 2ab cos c. So that's our cosine rule. So we are going to use it here. And again, you might be asked to find the bearing of the third point, because we are given bearing of 2 points and the distance between 2 points. So to find the bearing, so this is used to, cosine is used to calculate the distance. Cosine rule. Why sine rule is the bearing? It helps to calculate the bearing. So I remember sine rule states that if you are given triangle, maybe A, B, C, sine rule B, A, C, that A over sine A is the same as B over sine B, same as C over sine C. So that's our sine rule. So with this, we can get the angle. So let's now apply this in this question. And again, some question might be easy to use. SOHCAHTOA. Do you remember SOHCAHTOA? And again, SOHCAHTOA. Because some question might be that easy. We don't need to use cosine or sine rule. SOHCAHTOA. That sine is opposite over hypotenuse. You remember? Cosine is adjacent over. So some questions. So to solve anything in bearing, either we use sine rule, cosine rule, or SOHCAHTOA. So that's it. So let's look at this question. They said A, B, and C are points on the same horizontal plane. The bearing of B from A is south 30 degrees, and the bearing of C from B is 60 degrees. If AB is 5, BC is 3, find the bearing of C from A. So we can picture that horizontal plane as this vertical plane. So we have the started from 8, south 30 degrees. So this is my north, south, east, west. So A, from A to B, this is my B. So this is, they said 30, so this is 30. And since here is 30, here is also 30. And they said from the bearing of C from B, so from B, so C still open wider, so this is 60, and the distance, this is 5 cm, so this will be 3 cm. So they want us to get the bearing of, this is C, the bearing of C from A. So we'll connect A, and so this is vertical, this is east. So that's what we are looking for. We are looking for the bearing of C from A. So this angle from here to here. So let's call it beta. So for us to get beta, this is 30. So once we know this, we subtract the sum of these 30 and theta from 180, because the total angle here is 180. That's how we get beta. So I'm saying that from here you see that beta is 180 minus 30 plus theta. So let's get theta. Remember, here is 60. So we have a right angle triangle. So to get this theta, we use tan. No need of using sine and cosine rules. So we have tan theta is opposite, which is 3/5. Therefore, the bearing we are looking for, which is beta, is 180 minus 30 plus. Remember, if you make theta the subject of formula here, theta is now arctan of 3/5. So I'm doing it so that to avoid premature approximation. So I have plus tan, that's arctan of 3/5. So that's the answer. So 180 minus bracket 30 plus arctan of 3/5. So this is 119.03. So they told us to the nearest degree. So 119 degrees. So that's the answer. Very tricky question, but simple.